Bismillahirrahmanirrahim.
Assalamu alaikum students.
This is my second lecture of physics for 10th class. This is unit number 10, simple harmonic motion and waves. In this lecture, we will discuss waves, types of waves, and characteristics of waves in detail. In order to refresh your previous knowledge, I am going to discuss once again the vibratory motion. It is a to and fro motion of a body about its mean position. It is also known as oscillations. Now we will move towards our first topic, that is wave motion. What actually is wave motion? How would we define it? A wave is a disturbance in a medium which causes the particle of the medium to undergo vibratory motion about their mean position in equal intervals of time. As you can see in the animation, that a particle with the orange color is moving in up and down position in the orange circle. It is not displacing from its position, but it is just vibrating about its mean position, and it transfers the disturbance to its neighboring molecules. In order to understand the wave motion in detail, I am going to discuss an activity with you. For this, you have to take a rope and mark a point P on the rope. As you can see in the figure, that a point P with a black dot is marked on the rope, and tie one end of the rope with a rigid support and the other free end in your hand. Now flip the rope up and down in regular intervals of time. Now you will see that a wave will generate in the rope which will travel towards the fixed end. The point P, as you can see on the rope, will start vibrating up and down as the wave passes across it. As it is clear from the figure that the motion of the point P will be perpendicular to the direction of the motion of the wave.
So that is why it justifies the wave motion. According to the disturbance of the particle of the medium, waves are divided into two categories. One is your mechanical wave and other is your electromagnetic wave. Mechanical waves are those waves which require medium for their propagation, means they are medium dependent. It means that they can pass through solid, liquid, and gases, and without medium, they cannot propagate. For example, water waves, sound waves, etc. So, we know from the statement that they strictly require medium for their propagation. On the other hand, electromagnetic waves are those waves which do not require medium for their propagation, means they are not medium dependent. They can pass through the medium as well as they can pass through the space. For example, radio waves, television waves, X rays, etc. are the examples of electromagnetic waves.
Mechanical waves are furtherly divided into two types according to the disturbance of the particles. It is categorized into transverse waves and longitudinal waves. Now, as you can see in the figure, that the two figures are going to show the disturbance of the particles of the medium. Both the particles are disturbed differently in transverse waves and in longitudinal waves. Now I am going to discuss transverse and longitudinal waves individually in detail with you. Transverse waves. In transverse waves, the vibratory motion of the particle of the medium is perpendicular to the direction of propagation of the wave. As you can see that a slanky spring is used to explain the transverse waves, and that when we move the slanky spring in up and down position, a wave will generate. As you can see, the brown arrow shows the direction of propagation of the wave, and the red arrow shows the vibration of the particles of the slanky spring, and both making an angle of 90 degree. This justifies the definition.
Transverse waves can be explained with the help of a slanky spring. For this, We have to take a slinky spring and tie its one end with a rigid support, as shown in the animation, and the other free end in the hand. Now, if we move it quickly in up and down position, a wave of alternating crusts and trough will start propagating towards the fixed end. As you can see in the animation that the crusts and trough move perpendicular to the direction of the wave. So this justifies the transverse waves. The other examples of transverse waves are water waves, light waves, etc. Now I am going to discuss a very important property of wave, that is wavelength.
It is basically the distance between two consecutive crusts or trough is called wavelength. It is represented by a Greek letter lambda. It is measured in meters. As you can see in the figure that the distance between two consecutive crusts is represented by a red line and it is denoted by its wavelength. Now you should know what actually is a crust and what actually is a trough. Crusts are the highest point of the particle of the medium from the mean position. As you can see, the upper half of the dotted line, the upper half of the wave above the dotted line are denoted as crusts, whereas the lower half below the dotted line shows the troughs. Now, discuss the definition of trough. The trough are the lowest point of the particle of the medium from the mean position. Longitudinal or compressional wave, the second most important wave. We are going to discuss this very important example that longitudinal waves are the waves in which the particles of the medium move back and forth along the direction of propagation of the wave. As you can see in the animation, that one end of a slinky spring is tied with a rigid support and the other end of the slinky spring is gripped in the hand. And when you push and pull it quickly, a wave is generated in the spring. As you can see once again that two arrows are there. One is with the brown color and one is with the red color. Brown color represents the direction of propagation of the wave and red color once again represents the direction of vibration of the particle. And both the lines shows that both are parallel to one another, which justify the definition as well. Now I am going to discuss this example in detail. As you can see in the figure that we are going to use a slinky spring whose one end is tied with a rigid support and the other free end is gripped in the hand. Now when you push and pull it quickly in the direction of its length, a series of disturbances formed in the form of wave and it will start generating a wave in its length. These are known as compressions and rarefactions, which move back and forth along the direction of motion of the wave. As you can see in the animation, which is clearly described the compressions and rarefactions. Now first of all we are going to discuss the definition of compressions and rarefactions and then I am going to discuss this animation. Compression are the region where the particles of the medium are close together, and rarefactions are the region where the particle of the medium are spaced apart. As you can see in the animation that a series starts where the particles of the medium are close together and a series where the particle of the medium are spaced apart. These are the form of compressions and rarefactions, and the most important thing is that longitudinal waves have only two examples. One is the slinky spring and other is your sound. These are the only two examples for longitudinal waves. Now we are once again discuss another very interesting term, that is wavelength, just for longitudinal waves. As we know that the longitudinal wave does not move in the form of thrust and trough, rather than it moves in the form of compressions and rarefactions. So when we are going to discuss the wavelength of the longitudinal waves, the distance between two consecutive compressions or rarefactions is known as wavelength. It is again represented by a Greek letter lambda, and it is measured in meters. After having my lecture, I think you are able to do some questions. These are the very light questions, and you can find the answer of these questions from this lecture. As you can see that you can easily define the term wave. You can elaborate a difference between mechanical and electromagnetic waves easily with the help of examples. You are also able to distinguish between longitudinal and transverse waves with the help of at least slanty spring, which is explained already in the video. Also, you are able to draw a transverse wave with an amplitude of 2 centimeters and a wavelength of 4 centimeters. Label a crust and a trough on the wave. You should know where the crust is going to be placed and where the trough is going to be placed. What is meant by the word wavelength and what is meant by amplitude? What types of wave do not require any material medium for their propagation? I hope you will enjoy this lecture. Inshallah, we will meet in the next lecture. Until Allah.